Hey, John Gilroy here. Today, we're going to talk about quantum supremacy. It's got nothing to do with the James Bond movie. Hit the music, Manny. Welcome to the Federal Tech Podcast, the podcast that connects you to federal technology leaders. My name is John Gilroy, and I will be your moderator. Our guests today are from a company called D-Wave. We have Allison Schwartz, Global Government Relations Leader, and Murray Thom, Vice President of Quantum Technology Evangelism. First evangelist I've ever had in the show. Murray, how are you?
I'm doing very well, John. It's great to be here.
Actually, Allison, I've had Murray on 6-8 months ago, and we have a pretty good idea what your company does, but there are new people who want to listen, and there's new problems in the federal government, and I thought we'd bring Murray and Allison back and just try to figure out what's going on here. You know, I think of Quantum Solace and James Bond and, I don't know, Bourne Identity and all this kind of crazy stuff. So when I use a phrase like quantum supremacy, let's try to define what quantum supremacy is before we even get into this conversation.
Yeah, for sure. Well, you know, the notion here is that we are trying to establish a demonstration of calculations that quantum computers can do that are beyond classical computing, and that has now taken place. That's no longer in the future. That's now in our rearview mirror. It's a scientific breakthrough that's been published in Science, and what we were able to do is a calculation in 20 minutes that outperformed one of the most powerful supercomputers that we have today at the Frontier and Summit supercomputers at Oak Ridge National Laboratories. And it's solving a real problem, solving complex magnetic material simulation problems. And it's the first demonstration of quantum supremacy on a useful real-world problem. So, you know, quantum materials, those have a lot of relevance to applications in medical imaging, electronics, superconductors, electrical network sensors and motors. They're used everywhere in our everyday life. So it's a real opportunity in terms of materials discovery. As I mentioned, you know, this is not possible classically. So it would have taken 1 million years to do these calculations with high performance computers. And what's even more significant is that the energy savings from this calculation by doing it on a quantum computer is equivalent to global electricity production annually. You know, one of the fascinating things that we've now realized is that we have this new computational engine. And if we can take these tasks that are very difficult to do on classical computers and offload them onto quantum computers, we can fundamentally change the energy consumption profile of our high performance compute worldwide.
Good. So, Allison, you're sitting there in Georgetown, you're walking down, getting a cup of coffee, and someone says to you, yeah, I just did an interview about quantum supremacy. And you turn to them and say, you know, here's what it is. So what can it do for my govies?
So for the government, first of all, John, thanks for having us. We're really excited to be here and talk about it. You know, I am not a technical person, so I'm a policy person. So I am always fascinated when it comes to technology. You know, I might not know how my cell phone works, but I get really angry when it doesn't and doesn't do what I need to do. So the supremacy results and research is critically important, but there are applications that are necessary for this computational power to happen. So blockchain is one, AI is one. There's a variety of these heavily complex, computationally challenging use cases that face our public sector. Air traffic management is one. We obviously in the DC area know how important air traffic management is. The European Union just did a call for quantum computing, and it actually called D-Wave's annealing quantum computing technology near-term, high-yield, and low-risk technology. So as the government is looking at these optimization problems, whether it's magnetic materials or it can just be logistics and transportation, it can be scheduling, it can be making sure you have your trucks and cars ready to go when they need to go. You have that technology today to solve the problems today. This is not in the future. It is here today.
So Murray, have you read Chris Miller's book called Chip War?
I have actually.
Yeah. I'm reading it right now, and it's like a page. I just can't put it down. It's a great book. And I guess my takeaway is supply chain. That's my takeaway from that book. And supply chain is read the book. It's a very complicated problem, not just for the federal government, for all kinds of different companies and just sourcing and supply chain and everything else. And so this is a complex problem that I guess we can apply D-Wave to. Is that right?
Absolutely. And that's the thing is that, you know, I've been to, you know, supply chain conferences in the United States, you know, and the industry experts are saying that, you know, constant disruption is the new normal, right? Most important to be agile, you know, and when our customers are coming to work with us, it's because they see opportunities. They see that they can do better, and they want to be able to have higher productivity, not just for their systems, but for their workforce. They also want to have, greater agility. They need to be able to respond. Efficiency in doing the same thing over and over again is no longer of any value to them, right? So being able to, they're not just willing to be agile, they need the technology that enables them to be agile. And then in that context of responding, they want to be able to run efficiently. So they need to be able to reduce the load of the spare capacity that they're keeping that's just waiting in parking lots or off to the side of their shipping yards because they're not able to respond as well. And when we've worked with customers who are working on workforce scheduling in retail environments, they're using machine learning to figure out what their demand is every day of the week and every week of the year, and they're using our systems to produce schedules that are basically dynamically produced according to that time varying demand. So that's exactly, you want to be able to change your systems, and you need the technology to support it and allow you to achieve those goals. And that can be transformative when it's deployed across a network with the extent that our global supply chains have.
When you're looking at what the public sector is now being tasked to do, thinking of deploying old solutions for the same old problem is a mandate that the public sector cannot afford. So actually having to look at emerging technologies like quantum to be able to find new ways to accomplish the goals and services that they need to provide. Only quantum or quantum hybrid technologies are going to be able to meet those new needs.
Murray, everyone's looking for new answers and new solutions and be more effective. Tomorrow, I'm interviewing a general from the Air Force. We're going to talk about satellite as a service. Now, that's a flexible approach. And ground station as a service. Talk about flexible. So let's talk about your company. Is this quantum as a service, or what exactly do you offer?
Well, I'm so glad that you mentioned that, because for the customers that we're working with, on these, transportation logistics, on, workforce scheduling, on production scheduling, cargo loading. I mean, so many tasks, that are across the entire, federal space. Everything to do with resource allocation. That's where we're finding very early fit. And what we're able to offer with our cloud service is that our customers, we write programs that we give to our customers. They're able to run them and call our APIs. But on the other side of the API is all of our hybrid algorithms, all of our quantum computers, which we are constantly upgrading and improving, right? So it's a scenario where the incentives are really, really well aligned, because our customers want a simple interface. They've got a program, they control it, they're calling an API, they're able to get high quality solutions from it. And then they have an engine of innovation, which is the talented software developers, engineers, and scientists at D-Wave, who are all developing new quantum computing technology, new hybrid algorithms for leveraging it effectively to keep those customers on the bleeding edge of performance in a really easy to use workflow.
So Allison, when you talk to government executives, CIOs about this, do most people understand the whole concept of quantum, or is that just too mysterious?
No, nobody really understands quantum. And my favorite is when I started with the company, if somebody said they understood quantum, they were lying to you. The interesting thing is quantum has been around for a very long time. And the government, especially in the research areas of government, have been studying it. But how to actually deploy the technology, it really has only advanced in the past, 5 years or so, has been available in the cloud. There's now real-time cloud access, and you can develop algorithms that Maria was talking about today, identifying what are the right use cases. And those have changed. I've been with the company a little over 4 years, and the use cases have expanded since I started, and I'm so excited to see where it's going to come. But we're now trying to talk to those who are applying the technology to solve real-world problems, rather than the research sides of things that are the research sides of the government that we're looking at studying kind of how to make a qubit stronger and better and more coherent. So short answer is no, nobody really understands, but they're getting there. And the exciting thing is they're excited to learn.
The thing I would add to that is that, the thing that caused the GPT moment in the world was when something incredibly powerful became very easy to use. The traditional approach with quantum mechanics is, well, let's teach you all sorts of quantum mechanics. Let's teach you to be a quantum physicist. And most of the time, I'm talking to audiences, if I say, how many people here are quantum physicists, there may be 1 or 2 hands go up. And then I say, who wants to become a quantum physicist? Nobody's hands go up, not even the quantum physicists. So the thing is that I believe that when you're able to take something like that and turn it into an engine of useful work, it creates an opportunity to engage that's much easier. It's much simpler, right? It's about, hey, what's like I'm having much faster conversations with people where I say quantum computers do calculations that are too slow or too hard with classical computers. We've already been able to demonstrate taking tasks that would take 1,000,000 years down to 20 minutes. And we have customers who are running these in production, and it's bringing them value. For instance, like, NTT Docomo has optimized their telecommunications network so that as cell phone users are moving through the network, they are able to, they're sending paging signals to watch the movement and make sure that they reassign new cell towers to those cell phone users. They've managed to reduce the peak load of those paging signals by 15%. That increases the capacity of the network by 15% during peak loads, and they're deploying that across 250,000 base stations. So that's really tremendous value that people are realizing. And so when I'm talking to people that I meet, executives, folks in business, and I say, you can begin by just considering this part of your IT infrastructure, demonstrate for your business and your mission that you can bring a lot of value, bring a lot of transformative improvement so that you can start achieving those mission goals that you've got. And then after that, your team can start diving down through the stack and learning more and more about the technology. They're like, okay, yes, please.
Marie, on that point, the other thing that I talk to the government and the government sector about is you don't need quantum physicists. Who are your coders? Who are your algorithm developments, your data scientists, the ones who are already working on AI and ML, and they can learn how to train and algorithm development for quantum. And that is a huge game changer. That there are these online courses. There are ways to actually upskill your existing workforce.
With familiar programming paradigms,
Exactly.
and using Python code, so it's just the onboard is so easy.
So, Allison, I was taking notes, and Murray wrote down opportunity to engage. So we have an opportunity to engage with D-Wave here. I think Carahsoft has a special page for our listeners. Is that right?
Absolutely. The Carahsoft D-Wave for Government page actually has several different documents, including a new public sector ebook, which highlights many of these use cases, both on the civilian and national security side, of where applications have been developed or been deployed in order to address public sector needs. So I request that listeners go there and reach out, and there's some really great information. And if you have questions, don't hesitate to reach out because we are here for you.
Good. And I'll put a link to that in the show notes. So if you're walking your dog, I'll be able to go to federaltechpodcast.com and go to episode 235 and get it. So, Murray, I have grown kids, and they're all like twice as smart as me. And over holidays, we have arguments about past perfect subjunctive in Latin versus French. And then we'll talk about the two-body problem, three-body problem. And then we'll dance around with quantum and dance back. And I get pretty well lost. And I've studied this in many different aspects of it. And so you used the word earlier, annealing quantum computers. So what exactly is an annealing quantum computer?
Okay, so great question. If you think about the first question we're confronted with, which is what is a quantum computer? It's a computer that uses quantum effects to do calculations that are too slow or too hard with classical computers. That gives us a clue that quantum effects are a resource for the computer. So what kind of resource does it represent? Well, it turns out there's multiple ways that you can use it. You can use it to allow the computer to move between solutions more quickly. So you have a grocery delivery fleet, you're producing a schedule for them. The first schedule is, okay, but you want to move to a better schedule as quickly as possible. You want that process of moving to progressively better schedules to be fast. And quantum mechanics can help us with that. It's like a super highway to faster solutions. That's how it participates in an annealing system. That's why it's able to take these problems in optimization and provide our customers with better quality solutions. You can contrast that with other ways to use it for a quantum computer. You can use it to store more information. That's going to be very powerful and valuable when we start doing things like simulating molecules and how they bind with quantum computers. And that's a very valuable application. We're building systems that can do that. It's just that those are just a little bit further down the roadmap, and those applications as a result are further down the roadmap. And what's great is that with annealing technology, we really spearheaded that. We were the earliest and the first, and we're the only player with that technology available commercially. And we did that because it has these near-term applications. People can use them today and get value. We're the only quantum company with in-production quantum applications. Also, for the point we mentioned earlier, you don't need to know quantum mechanics to program those systems. So it's a significantly lower barrier to engage with quantum computers and get value from them. And the last reason is they're much easier to build. So we wanted to make it, I wouldn't go so far as to say that we're lazy, but we wanted to make it as easy as possible for ourselves. I like solving hard problems, but sometimes I wish they were a little less hard. And annealing systems are significantly easier to build. And that's why the largest, most highly connected quantum computers on the planet are D-Wave annealing quantum computers. So that's a little bit of a background.
So, Allison, I got a sports question for you here. So here's
Sure.
a tough one. So, Eagles win the Super Bowl, and and I've been an Eagles fan, and
I'm a New Yorker.
The Chiefs win something, I've always been a Chiefs fan. And, if you chat with people about this topic, people say, yeah, we're good at quantum. We've been doing it a while, and we know a lot about, but D-Wave really has done it for a while. I mean, you're not the newest kid on the street. I mean, like, oh yeah, I'm an Eagles fan now. No, I mean, you were into this years ago. I mean, when I first interviewed Murray, the website was funky. This website now, dwavequantum.com, it does look like a James Bond movie. I mean, it's a pretty cool site. So you got some credibility, don't you, Allison?
Yeah, absolutely. I mean, we've been around. D-Wave is not kind of a name that you hear at the kitchen table, but it will be soon. We have been around for, oh gosh, since 1999, I believe, and building computers and our real-time cloud access. We were one of the first quantum computers in the cloud. As Murray mentioned, we are the only quantum company with in-production applications. There's a variety of different use cases on national security and civilian sides where you can build this. This technology is real. It is tangible. Anybody can get access to it in the United States by going to dwavequantum.com and signing up for our Leap Quantum Cloud Access. There's an application, Murray was talking about scheduling for a retail grocer. There's an application that was built for a missile defense. And it looked at 67 million scenarios and provided an answer back in 13 seconds. No classical computer can look at something that big, provide an answer back that quickly in real time. And so it is real, it is tangible, and we're excited that we're able to provide real-world solutions across the globe.
So, Murray, when I was doing my research on your company, there's a phrase that came up that I haven't heard it's called quantum hybrid. So what does that mean, Murray?
So, it means that when you have a problem that you need solved, that there is a portion of the work that classical computers are best at, and there's a portion of the work that quantum computers are best at. And it's the correct coordination of those workflows so that they're solving your problem, getting you the best answer fastest. I think a lot of folks, quantum computers are complex processors and complex systems that we operate in. There are classical computers involved in the control and input and output of those quantum computers, but it's not to be confused with that. It's not just that, classical computers are involved in the system. It's that when you're solving problems, let's use the energy grid as an example, right? A traditional energy grid has like a central power plant, and then it has transmission lines that radiate out from it. Optimizing a energy grid like that is really, really easy to do with a classical computer, because every time the load increases on one end, you just ramp up your power to meet it. And what's going down the west grid line is not affecting what's going down the east grid line. You can just respond to them independently. Modern energy grids are not like that. We now have solar panels on people's homes. We've got vehicles, which are like storage capacitors for electrical energy. Sometimes they're drawing energy and sometimes they're pushing energy back into the network. As you're managing that network, you've got a series of decisions to make. Am I going to push energy here or draw energy from it? And the decision you make at each place in the network affects the rest of the decisions you have to make. Classical computers are terrible at that, and quantum computers excel at that kind of thing. All of these problems that we're talking about, these applications, involve both those elements. So we're not going to try to reinvent the wheel and get the quantum computer to do what classical computers are already good at. We can use quantum hybrid approaches and partition the workloads and get to more effective solutions more quickly. And that's been key in our pivot away from experimentation into operational use, which we have today. As we're moving away from toy problems into enterprise scale, mission scale problems, things that people need to solve in the real world today. And it's allowed us to move away from conversations about, well, there's some potential impact in the future. We can demonstrate return on investment on these applications with our customers and their missions today. So that's the key thing about that technology. And we began by open sourcing it. We were and certainly when I got started talking with customers in the government space, I was teaching them how to do that. And once we open sourced a framework, their response was, hey, this is great. I got a nice pat on the back. And they were like, but I don't want to have to be an expert in these workflows. I have mission problems I need to solve. I have launch windows. I need to get things out into space. I've got logistics in, constrained operating theaters, and I need to be able to optimize those. So can you handle that? And so that was when we were like, okay, we'll just make cloud solvers that people can, call with an API with completely anonymized data, and they can just get these extremely high quality results back. And then they can count on us to not only make sure that performance is high and have the high reliability that they need for those mission problems, like 99.9% availability and uptime, with calls to the quantum computer and sub-second response times, which is unprecedented but from anybody else in the quantum computing industry. But then that is constantly being improved for them. So they're getting that benefit. They're harnessing this like really powerful engine, and it's just they're continuing to accelerate on that path. And that's what I think, everyone would like the benefit of, because then we're cooperating the most effectively.
Yeah. Well, I think most of my listeners are dealing with pretty complex problems and getting more complex every day, flooded with data, all kinds of security requirements. And so intellectually, does someone who's working for the government now have to sit back and say, okay, I got a problem A, B, and C, and A is a good candidate for classical computing, and B is a good candidate for quantum. So how would you differentiate between the problem sets to figure out what's the right tool? I mean, when is D-Wave going to be the right tool? I mean, are there hints, are there clues, guidelines?
Well, I think, yes, absolutely. The first thing is that classical computers are so good that anything that's not causing you pain in your mission is probably getting well handled by classical computers, right?
Good place to start, yeah.
So if you have a pain point, like pull together your pain points and then come and talk to our team, and our team will help you by basically identifying here are the ones that are really key, where quantum computing can have its greatest impact, and then we can show you and build that for you. I think the key, when we're talking about these various examples, the thread that sort of involves them all are these decisions that need to get made, which are not smooth. Like if I've got only one glass of wine left, I can split that up between two people in any ratio that I want. But if I have a delivery that needs to get made, I can't divide that between two delivery drivers. One driver is doing it or the other. If I send them both, that's a waste of resources, right? Those are discrete decisions. And if they're, completely independent from one another, that's one thing. But in every organization around the planet, when you're allocating resources, those decisions you make impact one another. That's the fundamental feature. So any problem you're working on, whether it's in the artificial intelligence space, in the material simulation space, or in the optimization space, anything that has that feature in it, you're going to struggle to get to high quality solutions with classical computers, and quantum computers will be able to provide you benefit.
I also think one area that always was an aha moment for me was time to decision. There are certain decisions that the public sector makes that you can get the answer back in a day, in a week, or what have you. There are other ones you need it in milliseconds or minutes or less. So understanding not just the pain points, but what is that time to decision and the time to solution that you need. And that's where you have to identify, quantum, but also the right quantum provider, which is, do they have real-time cloud access?
Yeah, I mean,
That's good.
Our customers who have been working on scheduling tasks, we've got an application going into production. It's already through its first phase. It's going to save that organization, Pedersen Food Group. They own like 13 different grocery brands. It's going to save them 50,000 hours annually for their workforce. That portion of their workforce is the most senior members. Those are the folks that know the organization best, and they were having to spend so much time working on that scheduling task, and they didn't particularly enjoy it, right? Now they're able to get out from behind the back office and get out working with the junior employees, teaching them things, training them up, working with the people in their organizations with their customers, and that's a transformative impact for their people and their processes and their business. For folks who are in the federal space, who are operating on large scale networks and organizations with groups of people and resources, if you can take those most senior resources and reallocate them, so that they're helping you drive your mission success, why wouldn't you do that?
Yeah, I like the word resource, and I'm not going to jump into politics here, but I'd say as a general rule, 2025 is probably going to have some resource constraints on many federal IT projects. I think that's a fair statement. And what I've found is that it's not always bad to have your resources constrained, because then you come up with creative and new ways to do things using a different tool. Well, we never we're forced to use D-Wave now. We got to try something because I had 10 people last week. I got 8 people this week. I got the same deadlines. In fact, I've got increased volume. And so I think what it's going to force people into dabbling with something like quantum and maybe not get all scared about it, the physics involved and the, people going back and forth years ago, what it is, what it isn't, and all the lights back then. And we can detail that for hours and hours, but people getting to force into using a new tool of, hey, I am sick of this manual hammer. I'm going to have to get an air hammer because I got to do this whole roof and I have 2 less people on my crew. And so I think what's going to happen, Murray, is they're going to be forced to jump into quantum because it got too much potential saving money. It doesn't save money. Why should they? But if you have a case study, especially with, look at this small example, use the grocery store. Take a look at the VA. Do you think the VA has to supply food to any hospitals? Anywhere? There's 170 hospitals. Same food supply problem.
And the VA, it's not just from the food supply. We can actually optimize the patient care. The staffers are scheduling it to the patients that need to do it. In the VA, in their infrastructure, they also work in regions. So if a VA hospital service cannot provide the needed care, what is within that region that can provide that needed care in that time? D-Wave has built something like that during the pandemic. So how do you address kind of the patient needs and the resources needed to address the pandemic? If you're looking at emergency management, you cannot wait hours and hours for a response of a solution when you're dealing with emergency management. You're now going to have a variety of different resources that are at Federal Park Service. And how do you navigate the scheduling that Pattison Food Groups that Murray mentioned is a massively intensive man hour. It's the same thing in the federal government, from Air Force fighter pilot scheduling to maintenance to staff scheduling at the national parks. All of those can actually be made into a technology solution to open up man hours, open up those FTEs.
Yeah. And what I know from talking with people in the public sector, the defense space, the government space, is that they deeply, deeply care about their missions. That's what they're there for. It's so important to them, and they want to get and deliver those results. That their drive, their inspiration, their caring is deep. And when they're able to deliver that mission more effectively, it raises goosebumps, because it's so meaningful, and that's the joy of working and helping those customers to deliver that.
Good. We're running out of time here. This has been a great discussion. I think what's going to happen is circumstances are going to force people to try new solutions. And I think quantum is a solution they have to consider because it offers so much value. You have been listening to the Federal Tech Podcast with John Gilroy. I'd like to thank our guests from D-Wave, Allison Schwartz, Global Relations Leader, and Marie Thom, Vice President of Quantum Technology Evangelism. Thank you.
Thank you.